All right, welcome back to our next video in this GLTF authoring pipeline series. And today we're covering how to bake an ambient occlusion map.
That's right.
So actually, Ed, while I kind of lead us in with what ambient occlusion is, can you pull up a interesting model that might show us?
Sure.
So ambient occlusion, it's this detailing that you can put on your model where it's a way of toning down the light contribution. So think of it as self-shadowing of the ambient light that's coming onto the model. So if you had a tube, you would expect the inside of that tube to be darker because the ambient light is not reaching those inner parts of the tube. So Ed is bringing up, that looks like the default satellite in SDK.
This is the default satellite in SDK 11.7.
Okay, and so that model has an ambient occlusion map. So
it does.
Texture, just like we have a roughness texture and a normal map texture, there's this ambient occlusion channel. It's the single grayscale kind of factor that tells us how these various microfacets are darkened.
Yeah, so I'm going to turn off the solar panels here. We're just going to focus on the body of this spacecraft. We're going to head over to the shading tab so we can get a closer look at what this is. Now let's look at the graph that this thing made. The GLTF importer actually builds this graph when it imports a GLTF material, and it has a lot of different nodes and different images.
Right, and in GLTF, materials don't use this shader node graph building, so it kind of extrapolates it based on the definition that's in the GLTF
GLTF
model.
has a well-defined PBR material model, but it does not use shader nodes like this. So the Blender GLTF importer has actually constructed these nodes to try to teach Blender what was in the file so that Blender can render the same thing. And it does so primarily using this node, the principled BSDF node. And it has all the channels that were in the GLTF. It has a base color, a metallic, a roughness, a normal. And GLTF bakes together, or rather combines, three of these images. It combines an occlusion, a metallic, and a roughness image to I said them out of order. It's occlusion, roughness, and metallic image into the red, green, blue channels of this image.
Known in the GLTF expert community as ORM.
The ORM map.
Occlusion,
roughness, metallic.
Right. So each one of those channels is connecting. So we have two going to the principled BSDF, but I guess we do not have occlusion as a property there.
We do not. Blender did not offer a pre-baked ambient occlusion map as an input on the principled BSDF because originally this node was written for cycles. Cycles is a path tracer. It doesn't need a pre-baked occlusion map. It's just going to figure out the occlusion as it does its normal path tracing thing. But for a real-time system like GLTF, you might need a pre-baked occlusion map. It can help with the lighting.
And and to clarify, a rasterized engine really needs that.
One, yeah. So we're going to take a look. I'm going to cheat a little bit, and we're going to connect the red channel, which is that occlusion map, straight to the output. And before I do that, I want to come back here so that we can see our 3D model. And now I'm going to take that occlusion map and plug it right into the output. And what we end up seeing is all the rest of the texturing and coloring has gone away. I'm going to take that 3D cursor out of there too. And we're seeing no lighting effects at all. We're just seeing the ambient occlusion map. And it looks a little bit like maybe it's a white surface with some soft shadowing baked into it. And indeed, that's what this is. This is a map of which pixels can see how much of the environment around them.
Right. So at the base of a lot of these structures, you can see that there's that darkening right where those two edges join.
Where the edges join. And especially the darkest parts are inside the little thrusters here. The pixels in there are mostly have their view of the outside world blocked by the rest of the interior of the thruster. So they turn mostly black during the AO bake process. And some of these other ones that are on the outside surfaces stay white because they can see the environment around them. So this map is not directly shown to the user. It is meant to be a map of how much strength the the environment reflections really have on those pixels. So that there shouldn't be that much strength of, the environment reflecting off the inside of a thruster, for example.
Right.
As you would see a lot more on the outside edge.
So ambient occlusion, it's a real cheap and efficient way to give some visual quality, increase the contrast, and kind of really have some of your details in your model pop out. So it's something we want to see in our models. So let's see how it looks.
But one thing I want to show first, let me put this wire back the way it was. So we have our original material back. Something very odd is going on here. As far as Blender is concerned, the material output is just coming from this principled BSDF node. This node here gives every appearance of being a dead end. Information is going into it and getting lost. And in fact, it only gets more mysterious if you hit the tab key and look what's inside there. There's nothing in there. There's an input and an output. This, as far as Blender is concerned, this is a sort of a dead end path on the node graph of this material. And what's really happening is Blender has no use for this information, because if Blender were going to do path tracing, it would just figure out the occlusion. It doesn't need an ambient occlusion map. The Gltf exporter would like to get this information though. So there's this special group node, and if you've done this import, it shows up under this group selection. You have a Gltf Settings node, and it takes a setting called occlusion, and whatever image you put in there, the Gltf exporter will find it. Even though Blender's not using it, the Gltf exporter will find it and put it in your Gltf file as the baked ambient occlusion map for that material in that file. Does that make sense?
Makes sense. So we actually won't see the ambient occlusion when we're looking at it in the EV renderer.
Correct. Currently with this setup, it's not going to show an EV. At some point in the future, maybe they're going to add an occlusion input here. It would only be for EV. It wouldn't be for cycles. And if they ever do that, then we can change our exporter to connect the occlusion map right to that input.
Right.
And then you wouldn't need this little extra node.
Yep. But in our case, we are developing this model specifically for GLTF.
For GLTF.
So we need that node to kind of track where that ambient occlusion map is.
That's right. So I'm going to reload. I'm not going to save our imported satellite. And instead, I'm going to reload the CubeSat that we've been working on so far in this series. And we're going to see if we can bake some ambient occlusion for this little CubeSat. So let's head over to the shading tab and see what's going on. The last time we looked at this project, we were baking a roughness map. And I don't need that roughness map right now. I'm just going to dismiss it from the viewer. It's still in the project. And if you recall, the last time we did this, we weren't baking with the CubeSat itself. I had created this other thing called Bake Target 1. And we were using this to bake the roughness map with this image node down here that's acting as an output node for the bake process. And there are separate bake materials here. So we are going to create a new image to receive our AO map. And there's a little button here, new image. You can also use the new image button up there. And we'll call this CubeSat AO. This will be ambient occlusion for the CubeSat. It does not need an alpha channel. I like to stick a grid on when there's nothing else going on there. And it's defaulted to the color space of sRGB. We are not baking color into this image. So I'm going to choose non-color as the color space, and that tells Blender not to do any color space conversions. It's just going to take the linear mathematical values.
Right. We only want sRGB for base color and emissive.
Correct. Yes. So if you recall, there are two materials here. There's a frame material and a circuit board material, and I want to bake AO for both of them like this. And if you recall, in our UV editing, we have a nice combined UV atlas already made from a previous video. So that is the UV atlas that we are baking to here. So these materials are set. I'm going to come back to this panel, which is the render properties panel. And you'll notice I have cycles, the path tracer, and not EV, the real-time engine, selected. And this is important because when we're baking, well, it's important because EV does not yet, as of this recording, does not yet have a bake panel. But also, ambient occlusion is very much a path tracing kind of a thing. It's you're tracing rays coming out from the surface of the model. We're still set up from the previous video for baking roughness. I'm going to switch that over to ambient occlusion. And we're going to look at our path tracer here. The render rays are set to 128. I'm going to drop that all the way down to 16 because we are just doing sort of a rough draft. I just want to get a draft render of this AO to see, in case, for example, I made some horrible mistake during the first modeling video. And
unlikely, but still a good practice. Yeah.
But just in the off chance that may have happened and might become discovered later in the recording of this video, I will set this to draft mode. So we have everything set. We have our draft render. We have our two materials. Once again, it is important that this image node actually has this little white outline around it, because that tells it that is particularly the image node that you're going to bake to. That's important for the baking process.
Okay.
So I just hit the bake button. It's not going to take too long because it's only 16 traces per pixel.
And to clarify, you were doing that on the the render tab?
I was doing that on the render properties tab.
Okay.
Yes, with my bake target selected. And yes, and we got a nice image here. I see the backs of some solar cells are all black. They're actually encased by the solar cell coverings, so it's okay that they're black. The image looks pretty good, I guess, but it's hard to tell just from looking at the 2D atlas how good of a result that is. And plus, no one can see my horrible mistake yet. Actually, there's multiple mistakes in there. So let's go and do this. I'm going to come and duplicate my my bake target, and my duplicate, I'm going to rename it to bake target preview, and we'll use it to preview the output of the bake. So on the shading tab, I now have this preview object, and I'm going to come over to materials, and on the preview object, I'm going to delete out these baking materials and make a new material that is going to be a bake output preview. And this bake output preview, it's not a PBR material. I'm getting rid of principled BSDF, and we are just going to add in the image texture that we baked to, which would, in this case, was ambient occlusion. And it remembers it was non-color, and we're just going to dump that right into material output. And with that, we can actually visualize what our bake did on our 3D model.
Right. So we expect those cells to be black there because, as you said earlier, there's actual solar cell geometry that's
in front of those and covering those up. So it's okay that those are black. So that seems fine.
Yeah, I buy that. Okay.
What else? Uh-oh. What's happened down here? The whole bottom of this CubeSat is actually sinking into an object that you can't see. It's a noise test object that I made in the video where we talked about procedural noise, and it's messed up my occlusion map here.
The lacunarity got in the way there.
Yeah. So we're going to have to fix that.
Mm-hmm.
What else? This part of the circuit board pocket looks good. I've lost my panels. There they are. That looks good.
Yeah, hinges.
Hinges.
Black.
Hinges. What happened? The hinge is totally black.
Okay. So
we got some issues here, I think.
Right. So I guess why don't we turn on the normals, right? Let's take a look at this hinge thing.
Yeah. So what happened with the hinge, or what we think happened with the hinge, is that this thing is inside out. And let's go back to, let me go back to the main CubeSat itself. One of the things that I didn't do earlier is when I made these materials, really, they should be single-sided materials. And to get them that way, I actually, in this version of Blender, I actually have to go back to the EV rendering engine, because this is an EV property of these materials. You go and you hit backface culling. And that means that it's a single-sided material. It's allowed to cull away the back face.
Right, so you can only see the front side of the triangle, not the back side.
Right. Mm-hmm. We'll hit backface culling here on these materials. And since this is a baking video, I'm now going to switch from Eevee right back to cycles. But let's go to layout and see what has happened. My CubeSat is here. Let's turn on my whole CubeSat. So now we can sort of start to see the problem that, let's find flap 1 here. The hinge is in fact inside out. And because we had a double-sided material, it didn't matter too much that the hinge was inside out. But now with a single-sided material, you can see the inside of the hinge. So that's a problem. And for baking ambient occlusion, it's trying to figure out how much light is coming into the inside of the hinge. And the answer is none. And it colors it all black.
Yeah, I mean, the surface normal is actually a crucial piece to the ambient occlusion calculation. So if it's facing the wrong way, you'll find out pretty quickly.
Yes. And as it happens, when we were building this, we had the surface normal turned on. So if I look at it, it looks like they're poking out, but you see they go all the way into the center. They're actually poking in and then poking out the other side. So what I'm going to do is I'm going to go into Mesh, Normals, and I'm going to hit Recalculate Outside. Actually, there's a shortcut shown here of Shift-N to recalculate outside. So if I hit Shift-N, you'll see these normals flip like that. And now our hinge is right side out, as it should be. So let's go back to our bake target. And unfortunately, our bake target is a separate object, but it has that same issue. So I'm going to hit Shift-N on that hinge and fix that. So we fixed the inside out piece of geometry. We still have this other problem that we were seeing shadows of a bunch of other pieces of geometry, including this weird little noise test cube, put a big shadow on the bottom of our CubeSat, and some other stuff was going on there. So let's talk about this. This is, I hit Control Space to bring it up full screen. This is our view of the outline of this whole project. And there are little eyeballs down the right-hand side, but eyeballs aren't the only thing you have here. There's a bunch of settings as to whether or not objects can be selected, whether they're visible in the viewport, whether or not they're available for rendering. So this little camera icon here allows you to pick whether things are available for rendering. And that, again, that's from this drop-down, this filter drop-down, this restriction toggles.
Right. So when we're baking, visibility is not what's actually used to be input to that baking. We actually need to turn on the rendering.
A bake is a form of
visibility.
Render.
Yeah.
And so it's getting its visibility from the camera icons and not from the eyeball icons.
So that actually tells us a little bit more about why we're seeing black behind those solar panel cells, right?
Yes.
Because
it was
those weren't in the back or in the duplicated bake target, right?
Right. They're not in the duplicated bake target, but they're still on the original body. And even though they weren't selected for visibility in the viewport, they were affecting the bake and leaving those black shadows there.
Okay.
So I'm going to find the main CubeSat, which is this one, and I'm going to shift click on this camera, and it turns off all the children for me. And also my noise test, definitely I don't want to render that noise test thing. And also even my bake target preview, I don't want to render that either. The only thing I want to render during the bake is the actual main bake target and not even the preview of its output.
Right. Okay.
So now I have my bake target selected for visibility and for rendering. I'm going to head back over to my shading panel. And this is the image that was baked earlier. And we're still selected on both these materials. We are selected for baking to that AO map. We're back in cycles. We're still going to do a draft render of 16 path traces per pixel. And I'm going to hit bake. And once again, because it's only 16, the bake is going to go pretty quick. And now we see a much brighter image over here. So let's bring up my preview of this image. And it's still going to be grainy. So if I zoom in here, you'll still see some grain because it's just a draft render of this. But a number of problems have been fixed. My inside-out geometry.
Yeah, I saw the underside. The feet were properly colored at the bottom too.
The feet, let's check out the bottom of this CubeSat. We have a little bit of shading around the feet, which is what I want, which is in fact one of the main points of baking this AO is to get that little bit of shading around the feet. And then, but it's not encased in black from that stray object being in there. And likewise, the hinge is not inside out anymore, so that's good too.
Okay. I'm happy with this.
I'm pretty happy with this, but I think we can do better than 16.
Wow, right. I think we're ready to do
I think we're ready to crank
production
this
one.
up. So I'm going to pick 512 paths per pixel, and I'm going to hit bake. And I have to make sure that I'm not baking my preview. I have to actually bake my bake target and hit bake.
Okay, and I guess this is the part of the video where...
Through the magic of video editing, this part will be fast forwarded.
All right.
All right, so...
Looks like we're done baking.
We're done baking. We just fast forwarded a section of the video where it did a very detailed bake. And this is one of the things that I like, is that you're able to spend a lot of CPU cycles preparing something, and see we got a very smooth result with minimal dithering and granularity there. So you can spend a lot of time preparing a texture and then have a high quality finished result that just goes into the GLTF and gets used. When you have a result like this that you like, it's very important to come up to the image menu and hit pack. Otherwise, this image is not only unsaved, it's also not part of your Blender project. And by hitting pack, I've actually packed it into the Blender project. So the next time I save my Blender project, that image saves into the .blend file because it's packed in there.
Now, does the image need a user as well?
A lot of times I will do that. So there's this little shield icon called fake user, and you click it. And what that means is, well, Blender tries to optimize. When it saves a file, if it finds images or objects that don't have any users, it figures it doesn't need to save them. So by putting that little shield on there, it gives it what's called a fake user that tells Blender that, yes, even if there aren't any nodes, which right now there are, but even if there weren't any nodes touching that image, you should still treat it as being a quote-unquote used image, and it should still be saved.
Right. We're incrementing the reference count.
Yes.
All right.
Programmer speak. Okay, good. So let's go and apply this. There are a couple of ways to apply this. We're not going to apply it to our bake target, though. We're going to come back to our real CubeSat here and apply this image. One of the ways is, as before, if you import a model that already has one, like our satellite model or the Kronos water bottle sample model from the GLTF sample models repository. Yes.
Yeah, so those already have...
those already have AO. And there's a node here. You see it's highlighted. There's a node called Ambient Occlusion, but that's not the same as what GLTF is doing with Ambient Occlusion. Don't use that for this.
Right, so when you import one of those models, you already get one of... you'll get for free one of those group nodes.
One of those group nodes.
GLTF Settings node.
And I don't have one of those for free in my project here. I could import one.
Right.
I could actually link or append one from another Blender project up there, or I could create one the hard way. And the hard way is a little gnarly, but I'm going to show you guys what's involved in that. All right, so let's let's zoom in because I can't quite see that. So let's grab my ambient occlusion image. It knows it's non-color. And since I didn't take the time to import some other material that already had my node group, I'm going to have to create one by hand. And one of the things I want to point out is if I actually say make group and there's nothing selected, nothing happens. If there's no node selected, you can't actually make the group. So I have to add a throwaway node, and I've taken to using the invert node for this. Generally, you want to pick a node with very few inputs and outputs for this, but you need a throwaway node that's going to be destroyed just to get into the process of making a group. So I'm going to hit make group on this, and my original invert node was replaced with my new node group, and the invert node is now here inside the group. So we're in this green territory as the inside of the node group. And as I mentioned, this is a throwaway node. I'm going to hit X and discard it. And now all we have left are the inputs and outputs. And indeed, if I come over here, I just hit the letter N, by the way, to toggle that panel out. It's showing me these inputs and outputs. And I actually don't even need an output from this. I'm just talking to the GLTF exporter, and it just needs an input. And the input in particular it's going to need is called occlusion.
Okay, so this is an important keyword because the exporter is going to look for this occlusion property.
It will, yes.
Right.
And it actually needs to be spelled correctly for it to find it. OCCLUSION. So there's your occlusion input, and the node group itself, of course, needs a name. And this one is not case sensitive. You can type GLTF in all caps if you like. So there's Gltf Settings. And for this, I'm just going to take it and connect our occlusion map right there. So now, once again, as far as Blender is concerned, this is a dummy group. This is a dead end group. It's not touching the material output. Blender's not going to use it in the preview window, but the GLTF exporter will find it here and will export it as the occlusion map image. And if you recall, we have two different materials. So I'm going to multi-select these and hit Control-C for copy. And then I'm going to go over to my other material and paste them in. So these two materials, the frame and the circuit material, are almost identical. They have the same roughness map. They have the same occlusion map. They're in the process of becoming the same material. The only thing that's different still is the base color is different and the metallic value is different. And we haven't baked those yet. So for now, they need to remain separate. But once those last two channels are baked, then the whole thing collapses into a single material.
Okay. So when we export this,
yes,
will the exporter pack all, like our occlusion and metallic and roughness, all into a single texture?
It will.
Okay. So we get that ORM texture for free once we export.
Yes.
Now that we've set everything up.
Yes.
Okay.
And indeed, it will bake all, since we don't have a metallic map plugged in, it's going to bake all white for that channel. So let's pick our CubeSat. I'm going to hit select all. CubeSat is selected. And we'll go and file export to GLTF. As before, I told it to remember settings from before. We have selected objects only being exported. I have apply modifiers because I did some stuff with normal vectors during the modeling of this.
That's the auto smooth, yep.
Auto smooth is in there. And for Blender 2.82 users, I regret to inform you, we unfortunately discovered a little bug after 2.82 was released. So if you're using the apply modifiers and you're combining texture images, you cannot export shape keys. And in fact, this particular model isn't doing shape keys or skinning, so I'm going to turn those off. And that will be fixed in 2.83. That is a weird bit of internals, the little bit of internal data conflict between the image compositing and the applying of modifiers. So let's go into our GLTF. I'm going to export, as before, I will export a GLB file. We'll try it out. Oh, and there it is. We go to, there it is. We can bring it up in 3D viewer here. Seems to work okay. Let me also dip into, let me save this, and we will go into Visual Studio Code. This is a text editor from Microsoft. It's open source, it's free, and I've got a plugin here called GLTF Tools that will help us sort of examine the inside of this GLB file that I exported. So we will grab the GLB. This is video 7 or segment 7. Okay, so we tried to load a binary file into a text editor, and the text editor doesn't know what to do with the binary file, so it can't show it to us. But with the GLTF Tools extension installed, I'm going to right-click on the title bar here, and I'm going to say import from GLB, and we're going to explode this out into all of its pieces, the images, the JSON, the binary data. And in fact, because there are so many pieces, I'm going to make a separate folder for it. We'll call it CubeSat 3U version 7. And I'm going to dump all the pieces in that folder like that. And one more little point I'm going to make, if we take a quick look up here, this is ordinary text and this is italics. Italics is a warning. It means that's a temporary window. If you double click on it, it stops being italics, and then it's not a temporary window anymore.
Right. By temporary, meaning that if you did a search and pulled up another temporary window, it would just replace the contents of that.
Replace it. So I would recommend you make sure that that's like that. So now that we have this, let's hit the preview button and see if our model works. Here it's loaded into Babylon.js.
This also might, on the left side too, this is all human readable JSON. You can go in and make changes, change numbers, delete nodes to a certain extent.
Yes. There are some user serviceable and some non-user serviceable parts in here. And I would say that accessors and buffer views are essentially a directory of what's in the binary file. I consider those non-user serviceable parts. But certainly the texture images are all listed here. The nodes, the material definitions are all spelled out here. There's, if you recall, we assigned a strength to that normal map. It got copied in here.
Right, but if we wanted to see, for instance, what our model looked like with and without that occlusion texture, we could go in and delete that occlusion texture node and all references to it.
We could.
So it's... But the point is you have that live editing here that you can even then save it and see what the results look like in that preview.
Yes. So we could actually turn off, for example, an occlusion texture. And at this distance, it's not, in this viewer, it's not going to look too different. The Babylon viewer actually has a very strong direct light source that sort of overwhelms the occlusion map here. It might do better in the 3JS viewer. It's on this sort of a darker background. And I think you end up seeing a little more occlusion. Actually, right there, the fact that the foot is distinct, even if I line up the noise, you see a bit of brightness difference right there at the edge of the foot. And that's actually our occlusion map helping us out.
Right. In this particular model, it's maybe a little bit more subtle, but actually even the edges around those cylindrical hinges,
yes,
you do get that nice little contrast.
And let me show real quick this folder that I created. It didn't just get this one file that came up in the editor. It also got the binary data, and it got all of these images, which you could edit then in a paint program if you wanted to. But let's take a look in particular at this image. This is the combined occlusion and roughness images. So the roughness is actually in the green channel, and the occlusion is in the red channel. And then the blue channel is just all switched on everywhere because it was empty, so it's all ones. So we can find that in use. For example, in our frame material here, if you were to look at the occlusion texture, you see it's index 3, and then if you look at the metal roughness texture, it's that same index 3. So those are blended together. Index 3 comes from source 3. I'm hitting F12 to go to definition, and that's that same roughness and AO blend. And that's something the exporter did for us. It combined those channels that way to put them together. So that's sort of the intro to ambient occlusion and baking AO in Blender. And I hope you found this informative.
All right. Thank you.